Hello one and all, welcome to the Mathematics Show. In this one, let's take a look at writing the equation of a circle, beginning from complex numbers and making it into the xy plane. So, imagine we have a circle, and imagine that the center of the circle is the point 1 plus I. So the center is represented using a complex number. So then imagine some other point on the circle using a complex number could be represented as x plus y times I. That means there's a distance between the 2 points. So for example, I could make that equal to 2. So r equals 2 is the radius of the circle. Now there's nothing special about showing these points. What I'm about to show would work equally well, for example, if the center were the point -2 plus 3i or something like that, and you have some other point on the circle. This is all very general, but it perhaps helps when you have some specific concrete values in place to work with. So let's go to the next stage. What I'm going to do is first calculate the distance between those 2 points, between x plus yi and the point 1 plus I. So the distance will look like this. It's going to be x plus yi minus 1 plus I. That represents the difference, in other words, that little arrow that you see. Let's simplify that. And the bars around it, the vertical straight lines, those represent the fact that you're finding the distance, in other words, the magnitude. So what I'm going to do next is the following. I'm going to write here x plus yi, and I'm dropping the parentheses from step 1 and distributing the negative, so it's going to give you minus 1 minus I. At the next point, you want to group like terms. So when I do that, it's going to look like the following. I will have x minus 1 plus yi minus I. So I put the x with the -1 and I put the yi with the -I. Like terms grouped together, naturally enough. Let's go on here. So next I will have following. Just to emphasize what goes with what, I've put parentheses around x minus 1 and I've put parentheses around y minus 1. So what I did is I took the I, which is up there as yi minus I, and I placed it outside the parentheses by factoring I out. Now, at this point, remember we're finding the distance between the points x plus yi and 1 plus I. We know that value is equal to 2 because I just made that up. There's nothing special about 2. It could be 3, it could be 4. That's just made up. So what I'm going to do is I'm going to take this formula that I've developed here and I'm going to set it equal to that 2. So it's going to look like this. It's going to be absolute value, in other words, magnitude of the complex number that joins the points 1 plus I and x plus yi. That's represented between the vertical bars there. That is equal to 2, a value I made up. But now let's transition completely to the Pythagorean theorem, and it's going to look like that at the next point. So what have I done here? I took x minus 1 and I put it in here, so it becomes x minus 1 squared. And I took y minus 1 and I placed that in here, so it becomes y minus 1 the quantity squared, and that is equal to 2. So I'm rewriting the left side here using the Pythagorean theorem essentially. In other words, it's just an application of the distance formula. Okay, so let's continue with the next step. And next, I'm going to just take the square on both sides, and I need to do that because I need to get rid of the square root symbol. That means the following will happen over here, that the 2 here and the root symbol, I put a little slash across them to indicate they're going to cancel off. Lastly, let's work at the last step. It's going to look like this. On the bottom, I have x minus 1 that quantity squared plus y minus 1 that quantity squared. That is equal to 4. The 4 represents the square of the radius. So that is why it's 4. Now let's take a look at one last part, which is to make a picture out of this. So as an example, we could do it this way. Here's a picture. The center of this circle will be the point 1, 1. Where is that coming from? Well, that's coming from the fact that it says y minus 1. So that the 1, not the -1, but the 1 tells you the y coordinate of the center. Over here it says x minus 1 that quantity squared. So the 1 next to the negative tells you the x coordinate of the center. Again, +1, not -1. The opposite. So that allows me to mark up the center of my circle as 1, 1 within parentheses. And then after that, you usually just mark like an arbitrary point somewhere on the rim or circumference of the circle. So when I do that, it's going to be labeled now x, y. And the thing that is the same, whether you are in a Cartesian plane, which is what I'm doing now, or you are in a complex plane, which is where we began, is that the distance is a scalar quantity, a number like 2 or 4, what have you. And that's why this says r equals +2 still. If you compare the 2 representations of the circle, they are different but related, obviously. Take a look. For example, in the complex plane, the center is labeled with the point 1 plus 1i, if you want to be very careful. Again, 1 plus 1i. So there's a 1 and a 1 involved, nevertheless. And you see down over here, it's also 1 comma 1. So that really hasn't changed, you see? Further, in a complex plane, you have the coordinates x plus yi. So there's an x and a y present. And this new one here, in the Cartesian plane, it's also x comma y for the coordinates of that arbitrary point on the circle. And in this one, the radius is 2, the distance between those 2 points is 2. And when I look here, the distance between those 2 points is equal to 2 also. So the symbols that we use to represent these quantities clearly are different, right? Yet at the same time, they're also very much related, because after all, a point is a point. And the symbols that you use to describe it, you can vary, but it's still the same point at this level. So thank you so much for watching. Please leave a like and subscribe. I'll see you in another video.